This is a short, quick video to summarize and review how to solve radical equations, specifically square root equations, and check for extraneous solutions. Again, extraneous solutions mean it's a solution that we have got by doing everything numerically right, but it does not fit back into the equation, or it's a removable discontinuity. Okay, so we're going to work some examples because some of you were confused. 6 equals 3 times the square root of p minus 3. Before we get started, I want to point a few rules. First, we need to work it out where the square root with whatever under that root is standing alone by itself. So I need to use inverse operations to leave the square root by itself on one side of the equation, and it doesn't matter which side of the equation, by itself. Then I need to square both sides of the equation to get rid of the root. Then I will continue with inverse operations. So, since there's quite a few of you that still confused how do I use inverse operations to get the root by itself, I'm going to give a couple of few examples. For example, if I have -2 plus the square root of blah, 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 or can also look like the square root of whatever minus 2. These two are the same expressions. Same expressions. Here, we just have the -2 in front. Here, we just have the -2 after the radical. So, to use inverse operation, you need to ask yourself, what relationship does these two have? Well, we know this can be a little bit tricky if the number has a negative. So -2 plus x is the same as x minus 2. So the inverse operation here will be to add 2 to both sides. Again, here it's adding 2 because the 2 will just simply cancel that 2. So either way, they're the same expressions. Or we can have it where it's not negative, it's positive. So it's 3 plus the square root of blah, blah, blah. Or it could be the square root of blah, blah, blah plus the 3. In this case, use inverse operation and subtract 3. So we'll cross it out. That way I leave the root by itself. Okay, so these cases are for addition and subtraction. What if my root was multiplied by a number? For example, 4 square root of blah, 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 blah. Okay, so the relationship here, when you don't see anything, that means it's multiplication. So the inverse of multiplication is division. Okay, what if it was division? So we can write it as 1/3 of the square root of blah, blah, blah. Or it can be written as the square root of blah, 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 blah divided by 3. These two are the same, but make sure the root is only applying to the top part. So the inverse of multiplication is division, and the inverse of division is multiplication. The fraction sign always reminds me of division. Always reminds me of division. So in that case, multiplying by the 3 over 1 will take care of that fractions. Okay, so this will eliminate leaving the root by itself. Now, what if I just simply have a negative square root of blah, blah, blah? Then you just multiply the equation by a negative 1. And remember, what you do to the left, you have to do to the right. And what you do to the right, you have to do to the left. So looking back at our original problem, I can see that the relationship between the root and the 3 is multiplication. So the inverse of multiplication is division. So again, I'll divide by 3. What I do to the right, I have to do to the left. 6 divided by 3 is 2. Again, why did I do that? To eliminate the 3. No thinking needed. Eliminate the 3. This is equal to the square root of p minus 3. Okay? Now, once my root is by itself, you need to square both sides of the equations to get rid of the square root. So, square root of any number times itself. It has to be times itself equals to that number. So let's try that. Square root of 9 times the square root of 9. Square root of 9 is 3 times the square root of 9 is 3. Therefore, the square root of 9 times the square root of 9 is the same as 3 times 3, which is 9. Notice the pattern. Square root of 25 times the square root of 25 equals square root of 25, 5 times 5 equals 25. See the pattern. Okay. Or we can also justify it using power rules. Square root of a 9 is the same as square root of a half, because we learned that before, that the square root means a half, cubic root is a third, fourth root is a fourth, 10th root is a 1 over 10. So, if I square square root of 9, that means I'm squaring 9 to the half or to the power 2. Well, we've learned in Algebra 1 that when you have a power, parenthesis power, you just multiply the powers. So the base stays the same. Half of a 2 is simply a 1. So it's a 9. Okay, back to the problem. Using the rule, I'm going to square both sides. Remember, what you do to the left, you do to the right. What you do to the right, you have to do to the left. Okay, so 2 squared is a 4. Now, why did I square in the first place? Because I'm getting rid of the square root. So all I got to do is get rid of that root and just write whatever is under the root. So 4 equals to p minus 3. Now, I'm trying to solve for p, so minus 3, add 3 to both sides. So 7 equals p, or p equals 7. Okay? Now, to check for extraneous roots, we have to check. We have to check for extraneous roots. Because even if we graph it with a calculator, the calculator won't show it to you. You go back to the original problem. You plug in whatever value you have for p. Don't forget your square root. Now evaluate. 7 minus 3 is 4. Okay? Now, I'm not doing anything here. I'm just keeping my 6 all the way. So, square root of 4 is 2. 2 times 3 is 6. So, is 6 equals to 6? If you can draw a smiley face with 2 identical eyes, then it's a real solution and it's not extraneous solution. Okay, let's look at another example where our equation might turn into a quadratic form. So, in this example, I have the square root by itself, so I do not need to work any inverse operations. I need to start squaring both sides so I can get rid of my radical or my root. So, I'm going to apply square to both sides. So, the square root is removed by the power of 2. So, this is x equals 2. Now, watch out because this is a very common mistake. X minus 6 all squared does not equal x squared minus 6 squared. This is wrong. This is equal to x minus 6 times itself. You can do the FOIL or you can do the box. So x minus 6, x minus 6, x times x is x squared, x times negative 6 is negative 6x, negative 6 times x is negative 6x, negative 6 times negative 6 is 36. Combine like terms. This is equal to x squared minus 12x plus 36. Or you can simply say and memorize the rule. The rule is square the first, square the last. Always, always put that plus. First times second, all times 2. So x times negative 6 is negative 6x times 2 is negative 12x. You can do it either way. Okay, so on this side I'm going to have x squared minus 12x plus 36. Okay, so on this side we need a 0, so we're going to use the inverse operation to make this a 0. So x minus x is a 0. Remember to do it to the other side. So you're going to get x squared minus 13x plus 36 equals 0. So now we need to use factoring to break down the quadratic expression. I have 2 parentheses equals 0. Now, x squared can be factored into x times x. Okay. How do we factor the rest of the terms? First, we need to know if the signs are different or same. Think of twins. If they're identical, this is a plus. If they're different, this is a minus. So a plus sign on this side means they're identical twins. Now, what type of twins? This sign decides it. So they're both negative signs. Okay? Now, we need to find 2 numbers that will multiply into 36. So their product will give us a 36. So it could be 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. These are the factors of 36. So we're going to check each of these 2 and see which 2 will give me the sum of 13, the midterm. So 4 plus 9 is 13. So 1 gets the 4 and 1 gets the 9. Okay. So when we have 2 parentheses that have a product of a 0, so each one of them might be a 0. So x minus 4 could be a 0. Or x minus 9 could be the 0. Now let's solve each side. So add 4, x equals 4. And I'm going to add 9, add 9, x equals 9. So I've done everything correctly to solve this equation. Now it's time to check for extraneous solutions. So, check. So I'm going to go back to the original equation, which is x minus 6 equals square root of x. And I'm going to plug in the values I have for x. So if x is 4, then I need to replace my x's with 4. Now, let's check if this is a true statement. 4 minus 6 is negative 2. Square root of 4 is a 2. So I cannot have identical eyes. This guy is half blind. So this is not going to work. So this is extraneous solution. Let's check this solution. We said x is 9. So 9 minus 6 equals the square root of 9. 9 minus 6 is a 3. Square root of 9 is a 3. So this guy is a perfect guy with 2 cute eyes. So he's a real solution.